Okay, today I'd like to talk a little bit about scientific notation. Before we start talking about it, we need to know what it is. So, scientific notation is just numbers written as the product of two factors. And one of those factors is going to be greater than or equal to 1, but less than 10. The other one is going to be a power of 10. So, it's going to be a number that is greater than or equal to 1, but it's less than the whole number 10. So, and it's going to be times 10 to a certain power. So let's take a look at how to write numbers in scientific notation. I always start out with a template. I have a blank times 10 to the blank power, and then it's just a matter of filling in the blanks as we go. So the first step is going to move the decimal all the way to the left or right so that there is exactly one non-zero number in front of the decimal. And we're going to write the number formed in the first blank. So once we move the decimal all the way to the left or right to where there's just one non-zero number in front of the decimal, we're going to write it in this first blank. The second step is going to be to know that the number of places you move the decimal is the exponent of the base of 10. So however many times we move the decimal, that's going to be our exponent. It'll be positive unless you moved it to the right. So if it will be a negative exponent if you move the decimal to the right. So let's take a look at what this looks like. Our first example is 4,026. Well, the decimal in 4,026 is actually at the back. We don't write it because there's nothing on the right hand side of the decimal, so we don't need to show the decimal. This is just a whole number. So it's right here. We need to move it to where there's only one non-zero number in front of the decimal. Well, right now there's 1, 2, 3, 4 whole numbers in front of the decimal. So we're going to have to move that decimal 1, 2, 3 places and put it right there where the comma is. So there's where our decimal is now. The number in front of the decimal is 4. Now remember, it had to be a number greater than or equal to 1 and less than 10. Well, 4 fits that description. So I'm going to write this number, which is 4.026. That's the number that I'm going to write in that first blank. Now, to find the exponent, we go back and we count how many times we move that decimal. Well, we moved it 1, 2, 3 places. We moved it to the left, so this will be an exponent of a positive 3. So 4,026 written in scientific notation would be 4.026 times 10 to the third power. On this one, we're starting out with a decimal number, and so we still have to move this decimal until where there's only one non-zero number in front of it. Well, right now there's no non-zero numbers in front of it. Well, to do this, I'm going to have to move it 1, 2, 3, 4 places. So now the number in front of the decimal is a 3. And our 3 is greater than or equal to 1, but less than 10. So the number formed by this is 3.95, because I don't need all these zeros. They have no meaning. Okay? So we write 3.95. We moved that decimal 1, 2, 3, 4 places. We moved it to the left, so I remember that's a negative exponent. So that's going to be 10 to the negative 4 power. So 0.000395 is the same thing in scientific notation, 3.95 times 10 to the negative 4 power. All right, that's going from standard form to scientific notation. Let's talk about going from scientific notation back to standard form. Well, all we have to do is to move the decimal the same number of places as the exponent. Okay? We're going to move it right if the decimal is, if the exponent is positive, and left if it's negative. So in this first example, in scientific notation, I have 3.12 times 10 to the 5th power. Well, it's a positive exponent, so I'm going to move the decimal to the right. My number is going to get larger. So here's my decimal, and I need to move it 5 spaces. So when I do this, I'm going to move it 1, 2, 3, 4, 5. So my decimal is all the way back here. Now, I've got to put placeholders everywhere there's a hoop-de-doo, is what I call them, without a number in it. So I'm going to put zeros in as placeholders. So now I've moved the decimal 5 places to the right, so the decimal is now here. So the number that's created is 312,000. Okay? Put that comma in there to kind of clean it up, makes it easier to read. So 3.12 times 10 to the 5th power in scientific notation is equal to 312,000 in standard form. All right, let's take a look at this next example. It says 1.35 times 10 to the negative 4 power. Well, right now I know that negative 4 power, that's a tip-off that this is going to be a decimal as an answer. Okay, and it says if the exponent is negative, I have to move it to the left. I have to move the decimal to the left. I kind of think one thing that helps me remember that is I kind of think of this negative sign as pointing the way of the direction I need to move this decimal. So I need to take this decimal and I need to move it 4 places to the left. So as I do that, I've got 1, 2, 3, 4. So now here's my decimal. Well, I have 1, 2, 3 of these hoop-de-doos with nothing in it, so I've got to put placeholders. I've got to put zeros in there. So when I clean this up, I'm going to rewrite it as 0.000135. I always like to put a 0 in the whole numbers place. It just is a good idea to do that, okay? Because we know that there's 0 whole parts, okay? So just kind of review, when converting from scientific notation to standard form, you just move the decimal the same number of places as the exponent. You move the decimal to the right if it's a positive exponent, and to the left if it's a negative exponent. Guys, I hope this helps just a little bit, and as always, be sure to reach out if you have any questions at all.